the first meeting for today, we will speak about image processing. Some examples, some typical examples, only base level of image processing. The next our meeting, the second meeting, will be in Thursday, and we will speak about data analysis. It will be about correlation, regression, interpolation, fitting. It will be the second meeting. The third one will be in a week, exactly in a week, Monday evening. We will speak about vibration analysis, windowing, spectral analysis. And the last meeting, Thursday next week, we will speak about wavelets and Hilbert transform and signal decomposition. I suggest those who is interested in this specific subject maybe will follow this specific session, Zoom session, not that they don't need maybe to listen. Now let me open Matlab and we will start our session. Matlab. Okay, now the image processing. First, I would like to say that for image processing, our computer can use not only the computer process unit, CPU, but also the graphic processor units, and it's much more convenient and much more efficient. You can check if your computer has a graphic processor unit, just put in the line this command GPU device. And this is allow us to see if device. And you can start to start the section, you can use the button from run section, or you can just press Ctrl and Enter. GPU, sorry. And you can check if your computer has this unit. For example, my computer has a Quadra P2000. It means that it's a power external GPU card, and I can make this image processing much faster. Also, you can check if your Matlab has a required toolbox. If you put in your Matlab version 3 first letters VER and ask about your version, you can see all the list that you have in your computer, all toolboxes installed already. And for today, we need, in addition to the Matlab itself, we need the computer. Let me show you the computer vision toolbox. And also at the end of the session, maybe better to see the visual, but it's not necessary. We can use without it. Important only the vision toolbox. Now let's speak about the image as a base of the image. Our image is a matrix. In a matrix, we have X number of lines and Y number of columns. It's just a two-dimensional matrix, and with special coordinates, and each coordinate, it has a pixel, a pair of X and Y, and this for pixel for color image has also 3 numbers, and for black and white, it only has a 1 number. And as example, we will just open a file that is file onion. find onion, it already is inside in the Matlab. And by the way, you should know that Matlab has inside maybe 100 different image for demonstration, for examples of different procedures of image processing. When we read this file as onion, we can read file. To read the file, we use the function image read. And this file already has, we already have the name of this file, onion.png. When we insert the file in the Matlab workspace, now it is a matrix I, and we can show this matrix as a picture. Let us show, and I just close these two lines. Here is our picture. You see different vegetables, and they have the name onion.png, onion.portable network graphic picture. Now, because this is just a matrix, we can see the size of this matrix, and we also can see all the information of this file. To see the size is just regular Matlab operation size of our matrix, and image file info show everything about this image. Let me open it. Now you can see that the size of the matrix is 135 and 198 columns, and it has 3 dots because it's a multicolor picture. And the information about the picture itself, it has a file name, it is written when it was made, this picture, the size of the file, the format of the files, and all the details. Now we can use these information to see what it is in each point. Let me show you that, for example, our matrix has in the first point, has 3 numbers. It means that first pixel from the left corner, it has RGB values for this pixel. RGB, it means the colors are red, green, and blue. And the level of each color is just the number of this pixel. Now we can, for example, can hold on this our picture of vegetables, and we can we can just insert zeros for, let's do it. For example, we make zeros, new matrix is equal to zeros. And inside we can make, for example, 20 lines and, for example, 50 columns and 3 numbers of zeros, okay? Now, for these zeros, we can now show this file, image show. This was large. It's just black rectangular, right? But we can show this file together with our onion. Let's do it first, onion. Then we can ask to hold all this onion. And now you see we get our first initial file vegetables, and the left corner with 20 lines and 50 columns, it has a black rectangle. It's just to explain how it is built. Is image just a matrix, and this is the way it works. Now let's go to another procedure, very popular procedure, crop. It means that take a part of this image to take analysis of only part of the image. We can use, for example, built-in Matlab command graphic input to crop the image. Why we can do it? Because the image processing of Toolbox, it has a command image crop. By the way, you can see the help and explanation of each line in this file by pressing right button and ask for the help. For example, help of the image crop. We can open this window and we can see the explanation of the cropping command. And for example, here they use the rectangular to manage the part of the image that we need to crop. Okay, let's do it. For example, I need to take a part of this cropping, and I will use Matlab command graphic input. Let's do it. We can just use graphic inputs, and we need to measure in the image 2 points. And taking these 2 points, then we can round these 2 points with to calculate the index, because index should be integer number in the next manipulation. We just need to round our index and in x-axis and y-axis, and let's do it. Now, for existing image, I can ask for gene input. Let's do it. Here we have our image, and I ask the left upper corner and the lower right corner. Now we have 2 numbers, and we can calculate the rectangular. What is the rectangular? It is the following command. Why it is so? Because you can see in the help of the image cropping, it is written that rectangular should be the left x coordinate, the y top coordinate, the width and the height of this rectangular. We have here, so we can have the first coordinate x, the first coordinate y, and the difference between x and the difference between y, we will get the width and the height of the picture. Now, when we have all these rectangular coordinates, let's put the cropping command as it is explained in the help. And let's show our results. We already know this command, image show. And our new picture is Y1. Let's start. Okay, we'll start from the very beginning. To start it from the beginning, let me show image show. Where is our onion? Okay, and then graphic input. Image show. Graphic input. Again, left corner, right corner. And calculation. Okay, I don't know if you can see, but we took only a small part. It is a garlic from all these vegetables. And this way we can do cropping by manual operation. But Matlab has a very convenient way of cropping using built-in command, which is called image crop. Let's see how it works. It's much convenient. Again, first, let us use this onion initial picture. And we will use this cropping command. It will be just image crop, the initial image. Now I need just to put the rectangular, manual rectangle. Let's do another rectangle, for example, this one. Double press inside the rectangular will crop our area, and this is much convenient to get a part of the image using the Matlab image crop command. Now we'll go to most maybe interesting and important part of image processing called histogram, image histogram. It's a fundamental process, and in Matlab histogram can be viewed using the image histogram. This is a command, and again you can just open the help of this command and see this explanation of using the command. And for example, to use this histogram, we will use another picture, the picture called in Matlab rice. Let me show this picture. Here our picture. To insert the picture to the Matlab workspace, we need to use command image read. By the way, not only image read, we also can use image write to use our already built picture or done picture or drawn picture to write as a graphic file. We can just use a command image write. Now we can show our picture of the rice. Let's show it. Here's our picture, and let's now calculate the image histogram of this image, and it immediately will plot the histogram. Let me show. Here you can see the image itself and its histogram. Now about the histogram. Histogram is a grayscale image, represent the frequency of each level of the pixel. For example, from the left we can see black pixels, and on the vertical axis it's a number of these in this case black pixels. From the right we can see the white pixel and also the number of this white pixel. In histogram of the rice picture we can see there is a large number of gray and large number of the white color, but a huge number of not black but gray colors, that it's not so informative, because gray, it's not white, it's not a background black ground, it's just not interesting information about this great color. And this histogram can be used for different important procedures in the Matlab image processing. They could make sharpening and noise removing, deblurring, edge extraction, and other things very interesting. Let's start from the manual stretching procedure of the same picture, rice picture. To make this procedure, we will use the command in image processing toolbox, image adjusting, image adjust. Let me show how it works. Let's build a new matrix. As IA is image adjust picture from the original picture I, and we will use this number. What it means? Let me show you. In our initial histogram, we can see that from the left, the black colors, there is nothing, practically zero value of pixel with black color. We don't need this information. We can just stretch the histogram just from the number of number of great color, about 40. This is why we use 40, this number. But because the image adjusting need to use numbers from 0 to 1, we need just two relative numbers. That means that 40 divided by maximum number, 250. Now from the right side, we can see that the white color, there is nothing more than 200, sorry, more than 200. This is mean that we don't need more than 200, and for the white color, we use in input stretching the number 200 divided by 250. Now, when we made this calculation, image adjust, we can just show our new image. Let me show you. Let's show not only image, we also let's show again the new histogram, the stretched histogram. They are together. We just place the new image and place the new histogram, just two figures together. Let's do it. Okay, here are our new results. You see that stretched picture, it's much more interesting because we throughout not existing black color, not existing white color, and we get the stretched histogram and the much better looking our image. It's a very powerful procedure, image adjusting, for example, and also negative stretching. We can just do a negative stretching. For the negative, we can just replace the number of numbers of the command image adjusting. And let me show, for example, how to make from our negative rise negative. We can just put the negative picture. It will also use the same procedure. Again, we use the same procedure, image adjusting, the same our stretched picture, but we replace the output size of histogram, just replace the 0 and 1, because 0 it means white color and 1 it means black. White color is 1 and 0 is black color. Let's now show this this result, and also let's also put the histogram, the new histogram. The new histogram is IA new. Let me show you. Okay, here it is, our negative picture, and if you can compare the histogram, we just replace the black and white corner of the histogram. Here you see the black is much more higher than the white, and this is vice versa in the histogram. Also, the histogram can not only stretch the figure, it also just shrink the image. In some procedure, it's very convenient and it is required. Let me show how it works. We just play with the number of this histogram output numbers. Here's the results. Oops. Okay, and now we can just show this new image shrink histogram. Let's show also image show, image. Okay, now you can see, and also let me show again the image histogram together with the picture itself. It will be shrinked histogram. Here the result, the picture after shrinking and the histogram after shrinking. It just to lower the value of the contrast of the picture. Sometimes it is required, sometimes not, but here the procedure. Also very, very power procedure with the histogram. It just equalizing and just using equalizing procedure. It can just make the adaptive adaptive procedure to improve the quality of the picture. Let me show how it works, the histogram equalizing. Also, you can use help to see how it works, but we have the example also. The procedure to not here. Now we can show this result. And also again, we will plot the image histogram of this new result. You can see how much better the picture of our rice is now. Much contrast, very, all the details are beautiful. And the histogram is just equal level. It means that this image adjusting just can equalize level of black and white color and prepare the picture in practically in the best kind of the view of the picture. Also, we can move the picture in to make it more bright and maybe less bright. Here, the example is very simple. Let's first convert this to the conversion to make this picture from 0 to 1, not to 255 value of pixel. It's just the double value of the pixel from 0 to 1, all this number of this value of the pixels. And let's choose the bright value, for example, 0.2. And let's make a new matrix with more bright. We took our initial matrix D and we make addition of these to 20% of the brightness. Now we can plot this show of these new results, and also we can show the new image, new histogram of this brightened picture. Let's do it. Okay, here our brightened image and the brightened histogram. You can see the histogram is just moved, just slide to the white number of white pixels. We can go, but minus, we can go to the black corner of the image. Also, we can add some image together, or we can subtract images from one and another. It's also interesting results. Let me show how we can make just adding of two pictures, two figures, two images together. Let's close everything and make a new result. For example, again, let's read our already known picture of the rice. And also we can read another picture in the Matlab. For example, there is cameraman picture examples inside the Matlab. We don't need to download something external. And the main program to add is just image add. And we can just make two commands together just to image show the results. Then there is our results. It's image add command, two pictures together, I and J together as a binary pictures. Let's show what we get. Here we have this example of the cameraman inside the rice, just as an example of making the adding of making two pictures one on the other. Also, the important procedure of image processing is thresholding. It's required when we need to remove some unnecessary details from the image, and we need to concentrate of the essential details. And also it is used to bring out of hidden details. Maybe we cannot see them without this command. In the case when the object of the interest and the background have similar gray color, this command can just bring much better the result of the detail that we need. Let's show this thresholding how it works. We already have the initial picture image. I believe that we have. If not, we will get the error. We will use our image show our initial matrix. I don't remember if we have it. I believe that. Okay, let me show. And we just need to show all the pixels of the image, of the original image, that are number of pixels, not number, the value of pictures is more than 120. Let me see the results. Okay, now we can see that we can see only this result when the white color is much intensive. We see only white color. They are not gray, only the background gray, black background and white rice itself that are more than 120. Okay, now also important, then we use procedure sharpening. Image sharpening can make the picture better. Sometimes just emphasize the texture and drawing the focus of the picture. It can improve the image quality, but if the initial picture made without focus, this command cannot fix the picture. Just can make some maybe better result, but not the fix itself. Let me show how it works. Let's use this sharpening command here, for example. Image sharpening, the initial our matrix I, we need a round radius of the pixel for number of four neighbors pixel around all these pixel in the picture, and we will make twice the amount of sharpening, twice amount 2, and now we can just show the result of this sharpening. Let's see what we get. Also already, if we decided to put the picture also together with the image histogram. Let's do it now. Okay, here we can see
I'm sorry, Michael. Can you please explain what is SAG?
SAG?
SHG in line 51.
show graphics.
Ah, it's show graphics.
Of the last figure.
Show graphics. It's just to show graphics, because if we don't need this show graphic, we will not see the result immediately. The result show graphic window.
Okay, thank you very much.
By the way, to compare the original picture with the processed image, we can use the in-show pair.
Yeah, compare. We will use this compare in the next example. But here we can see that this sharpened picture showed, and also the histogram showed the more details, how sharpened was. It just make it more contrast between the background and the pixel with the white color. They make the more contrast between the background and the details in the pixel. And this just return the enhanced version of the grayscale of the picture, of the original picture. Okay, now let's go to another example, which will, here, let me stop and ask for the question. Yeah.
Michael, I saw that there are questions on the chat, so maybe you will give like 5 minutes for people to ask some questions before you go to the next example.
Okay, please.
I think mostly we wanted to know if there is any way to get the files here showing and also the recordings of these sessions. That will be great.
Yes, I will not allow to send you from the very beginning, but I believe that for the next our session, I will do it from the very beginning. But now I will send, after our meeting, I will send these examples already. You prefer to have everything inside the lines, right?
Yeah, sure.
Yes.
Okay, no problem, no problem. I will send this file with this example that you can use for playing with this image processing.
Much appreciated, thank you.
You're welcome. More questions?
Can you explain the parameters given to the function imSharpen in line 50?
50 image sharpening. Okay, this is the simplest way, just again that I say, you got just asked for a helping, and you also you can use the browsing in Internet Explorer. Here you see the example of this image sharpening, and this is the name which we use for sharpening and the value which use. And you can just see the explanation of everything. It may be much better than I am trying to explain. Just use the help, and to use the help, press the right button above again, let's do it. For example, we need something about sharpening. I just select the word. It could be done inside the section, any place in the code, in the text. Here also I can do it here in the text. I also can press right button and go to the help on image sharpening, and I can show in the small windows, and also I can go to the help browser and see the explanation in Internet, not Internet Explorer, in any browser. My default browser is image edge detection, maybe. I don't remember even what is it. Yes, it's edge. Okay. Any more questions, please? No questions, right? Let me continue. Okay.
It will help.
Yeah, sorry. Sorry, it was a question or not?
No, not a question.
Okay, not a question. Now let's go further. Morphological operation in Matlab. This morphological operation also, it's a main maybe point in the image processing toolbox. There is a lot of available procedures and algorithms, but the main procedure is using a command strel. Strel is just a structuring element. What it means that this, it just represents a structure which is essential for further morphological further operation. And as example, let me show what is structure element, what it is itself. Let's do a structure element as a square, for example. It's just using strel, common strel in the Matlab image processing, structuring element, and we will produce a square. And this structure element is a structure. What it means that it has a special substructure position. We can see, for example, we can see what is the neighborhoods of this structural position. Let me show you. Here you can see this structure element is a square. It is written that this is square, and the shape is square, and the neighborhoods it's 5 lines and 5 columns, and this is this matrix of this structure element. And also we can use not only square, we can see different structure elements. For example, here we can use a disk structure element, and also we can show you the disk. We can show you as a figure, as a picture. Let me show you the square. Here's our, so it's not this, it's a disk. It's a disk element, and we can see how it looks as a structure element. We also can use another structure element, for example, as a sphere, and this sphere can be used as another structure element. Here's our example as a sphere, and also we can show this structure element in here. We'll press the section around the section. You can see our square in the gridding, in the axis of 3D coordinates. Now, when we already have a structure element, we can use it. The first example of using the structure element is just removing small elements from the large figure. And let's open example. And in example, we will use Matlab built-in image that has a name snowflakes image. We ask image read to insert this image inside the workspace of the Matlab, and when we have already inside, we can just show the result, what it means, these snowflakes, how it looks. Let me show you. Here our snowflakes image. It's a great picture with different sizes of these snowflakes. Now let's apply our structure element like disk to this initial picture. Here the results of using this procedure. We just using the structure element disk, okay, and now we can apply the structure element to our initial figure, to our initial image. Okay, initial image is a region, and SE our structure element. When we use this IM open, we just remove all objects in the initial picture that are less than in size than 5 neighbor pixels. It means that small snowflakes will be removed from these results. Let me show you the results. Stroll and show the, let's show image show. Image show after opening. Okay, here the upper picture is just our original picture, and the new one, after removing small snowflakes, we will get only those that are more than 5 neighbor pixels in diameter. Okay, now very also important procedure, morphological procedure in image processing is dilation. Dilation is just adding additional pixel to the initial object to make a image maybe more clear. And inverse procedure of dilation is erosion. We also will make this example. Let me show, let me show the image dilation. Dilation, maybe in English we should say dilation. Here we can use this command image dilate, our original picture and structure element. Already we have the structure element as a disk, number of neighbor pixel 5. Now let's see the dilated result. The dilated result is here. Let me show it. Okay, image show. What is the problem? I know the problem is my, okay. You can see in this dilation, we have the same original picture, the first our original picture, and the last is just dilated picture with everything what was in the origin. Now it's much bigger, larger, and clearer. And the inverse procedure, it's erosion procedure. Let's see how it works. We will make another example. The third example, we will get, maybe we can take the initial, we can take the dilated, and also we can show this result and show these 3, and now we can choose erosion. Again, let's see but maybe better to see from the original. Let me take maybe another example from the original to see the difference. You can see how it produces the result. Oh no, it takes the, sorry, it takes rice. Where is our, so it's original, not this, it's origin. It's not rice, I would like to see this one. Origin. Okay, here the origin picture, the first one, and the fourth is just after procedure, erosion procedure of the original picture. Now, also important procedure in image processing is just extracting elements of the picture with the particular radius or particular level, value in the coordinates value. It can be also important for different examples of improving the the quality of the morphological operation. Okay, now we will subtract the result. Let's first maybe open, before we use the subtraction, let's apply the image open to remove small objects from the picture. We already know that we can remove from the original picture, our origin picture, we can remove all elements of snowflake that are less in diameter, less than 5 neighbor pictures. We also can remove from the original picture, we can remove the snowflakes. There are less than 6. There are less than 6 neighbor pixels, okay?
Michael,
Yeah.
there is a question if you can try to explain each of the last 3 commands once again.
Last 3
commands.
Which I put now?
Well, Dana, please ask him.
Please ask with microphone.
Hi. Yeah, so can you just repeat the meaning of the I am open, I am dilate, and I am erode? Just try and give a general explanation in simple words for each of them.
Okay, here we already used before. You see, we already have this example, removing small elements by using image open. Do you remember this example? When we use image opening, we just remove from the original picture, from original image, we remove the structure element. Each structure element that you would like to use. For example, in our example, we use structure element as a disk size 5. When we use this command image open, we remove from the original picture, we remove structure element, we remove small elements. From this example of snowflakes, we remove small flakes less than 5. Okay?
Can I ask a follow-up question about that?
Sure.
So if you have the first picture, it's probably pixels, which are zeros or 1, or maybe like in between, maybe in between 0 to 255, right? So how does it do it when you have the disk is a matrix 5 on 5
right.
with only ones? How does it do the math operation to remove those objects?
It just goes it follows every neighbor's pixel in all the picture and removed. You asking about small picture or large picture? What was the problem of this?
At line 12, you're trying to remove the snowflakes using the disk matrix, which is 5 on 5 matrix of ones. So the question is, how does it do it?
No, you see, just you see there is procedure. We can just go again to image open and see how it works. I believe that they have examples of using this. Here is the example that I took from their example, and we can use the explanation from here using this operation. I don't know exactly how it works inside the operation itself, image open, but I know that this applies the structure element to the image. If it is interesting to see inside this example, we can just maybe go to function, or maybe to let's check. Maybe it's inside the function. No, it's just morphological operation. I cannot explain exactly how it works, but it's algorithm to applying the structure element to the initial image. If you are interested, you can go to ask the help documentation maybe. because you know that the image processing I only use as a regular user. It's not my subject of expertise. This is, I cannot explain very deeply of each command. When we speak about vibration analysis or maybe Hilbert transfer, I can do it much deeply and maybe interesting. Okay. Okay, now when we stop in these three last examples, again, we apply the image open to remove from the original image structure element of 5 neighbors pixels, and the second line just remove from our original picture all elements less than 6. Now, when we use the command subtract the results, we will leave only radius of snowflakes that is only 5 pixels. Here we will leave only this exact radius. We will throw out small snowflakes. We also throw out the large than 6, and we will leave only 5 pixels. And here's the command image subtract. Now let's see the result of this radius. It could be the command of, but before we show it, Matlab recommend to make some better. We already know that histogram equalizing can improve the quality, the brightness and contrast of the picture, and this is the command to adaptively to improve the quality. And when we have this adjustment of the quality, we can show the result. This is recommendation of the image toolbox, twice using the image adjustment to make better dynamic range of pixels. Now let's show the results. Let us start. Okay, here we have only snowflakes with a diameter exactly 5 pixels. And this is maybe sometimes the main, the final maybe purpose of the analysis of some picture, to analyze and to extract the exactly elements with exact radius or maybe level of coordinates. Okay, have you more questions? Okay, let's continue to the edge detection. Example, edge detection also, it's very common image processing technique, and we can use it for application, for segmentation, for it also used for detection, for face detection. And the edge is just a curve inside the picture that follow to the changes in the image intensity. It can calculate the first derivative between the changes in the pixel, black and white pixels, and just estimate this maximum of the first derivative. Sometimes it is written that some algorithms of the edge detection using the not only maximum magnitude of the first derivative, sometimes they use a 0 value of the second derivatives of the intensity pixels. Now let's see examples with another picture that Matlab has inside. It's a coins picture. I also took the example from Matlab. Here our example. Let's show how it looks. Image show these results. Here different coins on the surface, and the picture show them just as a plane, in a plane picture. Edge detection has a number of different algorithms inside the image processing, and they can show, we will show some, for example, they have a example of using the edge detection using the Sobel algorithm. Also, there is in Matlab, there is another algorithm, Kenny algorithm. And we can compare these edge detection results by show pair they all together this picture as a montage, just two together. You can see image show pair, just two different picture as a montage. It means that together from the left hand side, and let's do it. Here you can see the result of image processing. It's all show this edge as a border between the background and the picture itself. Now we can maybe make it maybe better. We can just show the coins itself by connected components. Let me show how it works. We will make a new matrix X, 0 matrix, size exactly size as our original image of the coins. Okay, now we have only zeros. It means that we have only black color, the same the size as our original picture. Let's convert, let's show that, make calculation of our original, of our X matrix, and we will only use pixel where the value of the pixel is more than 100. It means that we will show only white color. And let us show these the results of X. Okay, now we can see that just by removing connecting components, we can just fill this edge detection, we will fill with the white color by using this command, by just connecting components in a binary image. We also can return these connected components, and we can just calculate them by using the command of black white connect components. Let me take this command, and for our X. Now we just calculate the connected components, and we have as a CC structure, Matlab structure, and now we can just make calculation of the labels of this structure. And having these labels, for example, we can see the maximum value, how many labels, how many coins we have there. Let's just process of all these commands. We have some errors. Where are the errors? Because, sorry, it was my fault. Okay, and we have the maximum. No, also we need, because it's a matrix, we just need to make calculation of each row. Now we can have the maximum value of labels, it's equal to 10. And let's see the results of our connected elements. Here we can show all the labels that we make a calculation and see each coin separately as a label. We can see them without background. We also can see them with the background. Okay, this way we can estimate the labels of the coin. When we have these labels, we also, the next interesting procedure is just to make to estimate the properties of the regions of the object. The measure can be made by the command region properties, and it is the command that estimate the coordinate of the centroid. It means the center of our object, and also the coordinate of the axis lengths, minor and major axis lengths of the picture. Let's make this calculation. Here, this example, making properties as a stats, as example of variable stats is a region properties. And we can make estimation of the diameters of each object and radius as a half of the diameter. And also we can estimate the show, maybe. We can just show the visible, the result can be visible by using the image processing command visible circles. If we have the radius and the label, we can just put the image of this circle, because we have centers and radius of each circle. It's very useful command also. And now we can also, let me show the results. Here we see the circles around each coins. Also, we can just plot not only the circle, we also can plot the center of these circles. You can see the center just with the black color and X. Okay, again. Centers. I believe that there is no centers. 6. Centers right. Hold. No, what was the problem? Sorry, I need to hold on to leave the initial coins picture. Okay, now we have not only the circles around the coins, but we can plot the center of this each coin, just center of this picture. We also can estimate the value, the coins values, how many cent is on the picture, how many money we have. Here the example how it works. We can play we can estimate this result according to the radius. For small coins, we have radius less than 27. At large coins, they have radius more, and small coins, they have radius less than 27 pixels, neighbors pixel together. This way, we can just put the text inside the picture itself. Let's try if it works. You see, here we can just put the value of each coin, 5 or 10 cents. We can see that 5 cents is a large radius and 10 cents is a small coin. By the way, I have a question. Somebody knows why the 10-cent coin is smaller than the 10 cent? Yes, 10 cent is smaller than 5-cent coin. Who knows? Because 10 cents it should be more, it's more money. But why the coin is smaller? Nobody knows.
Maybe the material for 10-cent coin is more expensive.
Right, you are absolutely right, because historically, maybe more than 10 years ago, the 10 cents coin was originally was made of silver. And this is why they cannot put a bigger coin, large number of material of silver. But the 5 cent, it's a modern coin, and they can make it from nickel, for example. They can any material as they want. This is why in the United States and Canada, this historically 10 cent, there is a small coin. Okay, and at the end of this example, we just can calculate how exactly money we have, because we know the radius. We can say the number of, as a sum of all radius that are less than 27 each are 5 coins, and the coins with 10 cents, they have more radius, and money that we have on the table, the value is, let's see if it works. Okay, we have 4 coins with 5 cents, we have 6 coins by 10 cents, and altogether we have totally 80 coins in our picture. This is the end example of the coins. If somebody is interested, you can make another maybe calculation.
Excuse me?
Right, yeah.
I cannot see the full line of line 57 and 58.
Sorry?
Can you scroll? I cannot see the full line of 56 and 50, no, 57 and 58. The full line, the coding line. Yeah, thank you.
Okay, show there is again at the end it's show graphic. SHG, it's show graphic, immediately show graphics. Okay. Any more questions? Okay, let's go to another examples of our, it's also interesting example.
Actually, you have 6 coins of 5 cents and 4 coins of 10 cents.
Let me check, maybe I just 1, 2, 3, 4, 5, 6. Right, it was my mistake. I do it. Let's change the, it's more than here, it's less. Thank you for correction. Now it's correct?
Yeah, thank you.
Thank you, because it was my fault. yeah, to make a calculation and count money, it was always my problem, but now we have it, we did it right. Okay, let's go to another example. It's just, we can took this example. Let me show this example from made in the Johns Hopkins University. It is a example of picture, or if I'm not mistaken, it's an image of a cell from the prostate cancer. And they published and they use Matlab to analyze this figure. We also can make analysis, and I will do it maybe more quickly because we have some more examples, interesting examples that I think that we should see them. Again, we will show this detect entire cell. We should use the edge procedure, and this procedure is looking like this. Okay, we use again this Sobel example. Sobel. Sorry. Okay, now we can just take any factor, because the threshold is just a priori not known value, but we can just, for this error, we just take any fudge factor as we wish, and we can make this edge detection of this picture. And also, let's show me the results of this edge detection. Or maybe title, we will put separately line. White binary title. Mask. Okay, I believe it's okay. Let's show if it works. Okay, here are the results of the image, of the edge detection of this cell. On the next step, we can delete the image, but this deletion, we will use a new structuring element. It calls line element. We will use to improve the contrast of the image, and these linear gaps will disappear when we use this structure element. Let us do it. We'll use two structure element line that are perpendicular each to other, and the next step, we can delete the results of the image, and let's show the results. You can see first we just fill all this edge, we fill with the color, and we delete, we enlarge every elements to make this fill, all this border of this cell, we fill with the pixel, with the white pixel. But still we can see some erosion from the side of this cell. We can fix it, but using image clear border, the special procedure that can clean the border of the picture. And also the next problem, we have not only one cell, we have also the next one, which each on the corner. We should also remove this corner cell. Let's do it. Our next procedure is remove the corner, and let's show the result. Image show, black white, border removed. Let's see if it works. No. Image border will fill deal.
No fill.
No fill. Let's fill first. Delete it's here. Here we have the filling image. Fill this white color. Let's see how it looks. Here we fill every black pixel inside. We fill it with the white color, and now we can just remove the part of the cell that is connected to the corner. Let's do it. Okay, now we have only our important cell just alone, and we can continue. We can smooth the object. Why we need? Because here we can see some not exactly parted elements that are connected to the cell itself. We will use this structure element as a diamond. Remove, smooth the element. Structure element of diamond. We can show the result. Let's see if it works. Okay, here without removing it, now we have pure cell. And also we can maybe in this last stage, we can maybe make a visualization of our segmentation. We can make a label. Do you remember that we made label for the coins? Now we can make this label for this cell. It's two procedures together. The first is label overlaid by our cell, and the image show just can show the results. Let us do it. You see, we fill our final picture with this overlay with different. We can fill it with different color. We not only can fill it, we can also make a contour. To build a contour, and let me show how it works with the contour. It just built an outline at the contour around the segmented cell. Here is the perimeter. The command is black-white perimeter of our picture. And we can choose the color. For example, when I use 255, it will be the white contour, the white color of our perimeter. Let's see. You see, we have our cell with the white contour. Also, we can maybe make it black when we choose this for 0, for example. I believe that we will get a black color contour. You see, there is a black color. This is example of extracting the object from the number of elements. We can just emphasize and take only what is important for us to further analysis. Please, questions about this example of Hopkins University?
Yes, please. If you could explain the command BW perim in line 35.
Ken, it's a perimeter. Perimeter is just, we have a element, isolated element. Here's the picture, the image is black-white final, is the element. Black-white perimeter just estimate the contour or perimeter of this element. How it works? It has a background of the picture, and it has our label. It is filled with the color, and it calculate the border between the difference between the background and fill the labels, and just put the line, the curve out around our element. We also can see the help of this command, and we can do it in browser. It's maybe here you see returns a binary image that contains only perimeter pixel of the object, input image, black-white image. And it can be used to find perimeter of object. We already can use it with the circles, for example, or other object, but I prefer to use it with this cell because it's more practical. It's taken also from Matlab as example. Okay?
Okay, yeah, thank you very much.
Thank you. Okay, we have some time, more time, maybe 5-10 minutes. The most maybe interesting, but rather complicated example of tracking objects inside the image. There is no large difference between the image and video. What is the video is just a number of images taken with the frame frequency, and there is an array of many pictures. It's just a movie. And object tracking is just a procedure that can locate a moving object, or maybe several objects, over time in a video stream. And taking an object, it's not only to detect the object. It's tracking object, it is also to track and to make this analysis for multiple frames. Here I can show you, I believe that everybody has video, how to say, video toolbox. And if not, you cannot see this example, but in my computer it has already, and we can just play this video. Let me do it. Okay, this is example of the video. We can just put it around without stopping. What we can see in this playing this segment, we can see the green ball that goes from the left corner of the picture of the movie to the right corner. Also, there is a box inside where there is no results of the trajectory of this ball. And the tracking, it's not the only analyze the trajectory that we can see, it also predict the location of the object when some part of the moving, we cannot see the part of the moving. Matlab has a very interesting example of this tracking called tracking via Kalman filter. Kalman filter, it's not maybe the most important here, but we will maybe concentrate on this Kalman filter tracking example. Let's stop our movie and maybe close it. And let's start the example of this vision. You know, it's a rather large. I believe that you can yourself. I will send you this file with this example. You can open and analyze all this procedure. In our example, I will only maybe start this example to see how is possible to make this tracking of the object as a part of the object is not visible. Let's start this example. Okay, it's too maybe quick, but okay, the first picture from this first figure from this is just one frame from the movie when we can say a stopped image of this green ball. And here the result of this tracking. We can just detect trajectory of this ball, and for different tracking and for different detection. And the resulted tracking, here is the last picture, this is the tracking results on, of the ball. I suggest somebody who has time just to read and to play, because this can be made at home in your Matlab and to analyze how it works. Also, I for the last maybe example, let me show you another example of monocular visual odometry. What it means that try to analyze the location of our camera if we use only the picture that camera produces. Let's also open this example. And here also, no, okay, let me maybe run this example. I believe it will go because I have a graphic processor. My computer has a graphic unit power. It will proceed quite quickly. I believe no more than several minutes. We can see here the movie when camera was moved inside the room and made some pictures inside, but we don't know exactly the trajectory of our camera, and the purpose of our analysis is to build this trajectory and to analyze this, to build it inside the coordinates. And I can show you the results. I believe that there is at the end. Here it is. Oops. Here you can see the result of camera trajectory. This was identified according to the movie analysis of the camera. Now we can say that the camera was moved inside the 3D, inside the room, exactly according to this trajectory. And here we can just compare. They have the actual trajectory they measure and the estimated trajectory using the Matlab. And also maybe the last thing that I would like to tell you, that you can play with also very interesting result in the, let's close this. Also, we don't need, we just open Matlab itself. And everybody can play with your computer. I believe if you are participated in our Zoom session, it means that you have this camera in your computer. I suggest that you download from Matlab the additional hardware addition that is called USB web camera support. You can do it by pressing environment, add-ins, and in add-ins there is get hardware support. And for the searching, you can put just 3 letters, USB, USB, and look for this support. Here the first is Matlab support package for USB web camera. You see I have a green label here that is installed. I already have it, but somebody who hasn't, please download and install in your Matlab, and this way you can play with the example of face recognition and see how Matlab available to test your movement next to the camera. Let me show you. First, you can check this web camera by using the command. After you install it, you can put this command web camera list. And for example, my computer explained that my computer has Microsoft Live Camera HD 3000, and I can use it for this face tracking example. In our Zoom session, I cannot show you how it works because my web camera now it's occupied by Zoom session. But you yourself, you can try to use it and check this example of face recognition and face example of these very interesting procedure, not procedure, examples of face recognition and also face tracking in the example. This is, I just put maybe 10 minutes for questions, and this is the end of our first session dedicated to image processing. And I'm ready to your question, please. No, I believe that there is no
Michael?
Yeah.
How did you get to environment?
Environment?
Yes.
You mean how we environment in the
in the tools above
web camera? Just
yes.
You in your please open the Matlab, the main Matlab window where you have the main ruler of the Matlab. Can you see here, for example, new script, new import, everything?
I see, but I don't think what is in the right.
Environment.
The code, simulink, environment, it's not appears in my computer.
You have no here code, simulink, environment, you have no? Maybe just enlarge your window. Maybe this way you can see add-ons maybe. Just enlarge in the horizontal way, just enlarge your window. Maybe this way. Can you see these add-ons?
Yes.
Now press this button, this small triangle, and go to the Get Hardware Support. Can you see it?
Yes.
And in this Get Hardware Support, just choose USB.
Thank you.
Okay, you're welcome.
Excuse me, can we next time have a small break for 5 minutes just to go to the bathroom?
I think that, Ruben, can our participants have in the middle of the session have a small break, 5 minutes? What do you think?
Yeah, of course they can, but they have to sign an agreement that they will come back.
Okay, let's first, okay, close.
Can I ask something about the previous example?
Yeah, sure.
The one with the cell, yeah. When you remove the other connected component using, what was that? Clear border, I think.
Yeah.
How did you know which component will it remove?
You see here, you just ask for the number of neighbors elements. It's not so important. Just here we can just try if it works with another number. Let me see if it works at all. Okay, it works. Let me see if we can just make some smaller. No, I don't remember.
I mean, how did you know that you're not removing the one you're not interested in?
Right. Let me check, maybe help. I don't know, but maybe they know. they have a connection structure, specify the pixel connection. We ask for 4 connection. Sorry, I don't know why exactly 4 it works, but maybe more. It also can. Let's check if it works with a more number. No, it only works with 4 numbers. No, sorry, I don't know. You know what I would like to say to everybody, that today this not only image processing, but exactly all this signal processing, it all is more than mathematical procedure. It's more art maybe today, and it according to the author what to use, because the same result can be achieved by different algorithms. It's just kind of art to take some algorithms and make this combination and get the result, the required result. But it's, 50% it's art and 50 mathematics. And in your clean and border, I don't know. We can just maybe read about the documentation about this in clear border procedure. Sorry.
Okay, that's okay. Thanks.
Michael, please explain what will be in the next session.
The next session will be data analysis. What means the data analysis? It will be analysis of random data, of linear data, non-linear data. We will speak about fitting, about interpolation, about correlation, about regression, about outer RLX model. Just analysis of data. I would say, from my point of view, it's slow data because it's not high changing results like vibration or acoustic analysis, but just data analysis, signal processing in modern data analysis using the regression, correlation, and statistics toolbox. It will be in a day, just Thursday evening.
Michael, I'd like to say thank you for the workshop and to ask you how much do you think effort should an engineer put inside of learning these kinds of knowledge, like the image processing we learned today, in order to start work on projects for PhDs or to find a job? How much time, or how would you do it if you want to start working on that, or on a project for entrepreneurship or something?
If you would like to start with a project, it could be a semester project or maybe a year project. It's enough maybe several weeks to be just acquainted with all this main procedure, that's principal procedure in image processing. But it's not enough to convert this subject to your profession, to your real specialization. Because here in not every, but many faculties has a special direction, special field of image processing. For example, our faculty, our mechanical engineering faculty, has a special laboratory for image processing. It's CAD lab system for computer-aided design. For example, electrical engineering faculty has a power laboratory of image processing. The computer faculty has also a special group for image processing. To be a real expert in this field, I mean that you need several years to work with the image. But speaking about the project, I mean several weeks is enough to make an interesting project.
For a good start, several weeks is...
Yeah, to good start. But if you are a student in a particular faculty, just choose the subject. Maybe you are speaking particularly about image processing.
Not specifically all the subjects we cover in our signal processing. I'm a Master of Science in Mechanical Engineering, and I'm just looking at new kinds of ways.
Right. For example, the same problem was for myself when I tried to concentrate and to find for you for meeting to find some interesting. It should be interesting. It should be maybe simple enough to show to explain, and maybe also it should be useful for you. Maybe in your work as a student, you can use this procedure as signals, statistic analysis or vibration analysis or wavelets analysis. But you know, Matlab has more than 100 toolboxes. And today we spoken only about one of them. Do you know how many toolboxes and procedure we have? Nobody knows they deep enough, everything, but just took what is interesting. I believe that everyone can choose for his heart what is more interesting. I know what I'm interested in. I like vibration, but somebody maybe like something else.
Thank you very much.
And Michael, could you please send us the code? I didn't manage to copy all of it during this session.
Yeah, already I promised to send to everybody the files that I use for this example. I will use this example. I fill all this procedure, check them, and will send them to you. But maybe for our next session, I prefer to send to you maybe for the second session, just empty file that we will use together, that maybe you will follow me to use this procedure, because following, we believe, will allow you to remember, to understand deeply all the line. But if you just...
Yes, this is what I did during this session, but I didn't manage also to listen to you and to copy, because most of this is me.
I see.
So, yeah, no. So maybe just the longest lines.
Okay, I will maybe leave longest line. I will leave already filled in, and we will put maybe short. We will put together, because you know we as a teacher we think that you as a student you should work, not only listen and see, because this
of course, but just the long lines. Thank you.
Okay, settled. We will do it. Any more questions? Okay, Ruben, I believe that we just can end our session. I will stop sharing, and also I will stop recording.